Good morning. So yesterday, last class we discussed about particular integration when q is equal to x power k into v form. So in this class we will discuss about linear equation of second order with variable coefficients. So first of all, what is linear equation of second order with variable coefficients? So please linear equation of second order with variable coefficients. So in previous classes we discussed linear equation with the constant coefficients. Now in this class we will discuss with the variable coefficients. So what is a linear equation of second order with the variable coefficients? So now the equation of the form d square y by dx square plus p of x into dy by dx plus q of x into y is equal to r of x. Now here p, q, r are function of x. Now then this is called a linear equation of second order with the variable coefficients. Now how to solve this second order with the variable coefficients? Now to find this equation, to solve this equation, the general solution of second order variable coefficients. So p of x into dy by dx plus q of x into y is equal to r of x. Now the solution of this differential equation. So to find the solution of this differential equation, first of all find complementary function. So for the complementary function is of the form c1 u of x plus c2 v of x. So after getting complementary function, here we get u and v. So now to find particular integration, that is yp or pi. So then let particular integration yp is au plus bv. Here u we are getting from complementary function. Now here let yp is au plus bv. Now here what is a and b? So here a and b are where a is equal to, what is a here? Now a is minus integral v or u by uv dash minus vu dash into dx. This is a. Now write b. What is b here? b is integral u r by uv dash minus vu dash into dx. Now these are the a and b. So after getting these values a and b, substitute in a particular integral, that is yp. Now substituting this we get yp. So now the general solution is, after getting yp and yc means here complementary function yc. Therefore the general solution of this differential equation, the general solution is write as, so here y is equal to yc plus yp. What is yc here? c1u plus c2v plus, so now yp is au plus bv. Now what is a? Here a is this one and b is this one, right? Now here uv dash minus vu dash. After getting u and v, for calculate uv dash minus vu dash. Now actually here where Wronskian of uv, this can be denoted with Wronskian of uv, that is uv dash minus vu dash. This is the procedure for finding linear equation of second order with a variable coefficients. Okay, right. Next, we'll discuss one problem. Now, the first problem is solve d square plus a square of y is equal to tan ax. This is the problem. By method of variation of parameters, by the method of variation of parameters. Now here actually the solution c1u plus c2v and the particular integration yp is au plus bv, then solution yc plus yp. That procedure is variation of parameters. That method is called variation of parameters. Now solve this differential equation by variation of parameters. So now first of all find complementary function. Here now what is here, f of d is d square plus a square and r of x, that means r, here r is given tan ax, right? Now complementary function, to find complementary function, the first write auxiliary equation. So what is the auxiliary equation? Here auxiliary equation is write as f of m is equal to 0. Now write this one, m square plus a square is equal to 0. Now here m square is equal to minus a square, then from that we get m is equal to plus or minus ai. Now these are the complex roots. So what is the solution for complex roots? So we'll compare with the complex roots, compare with a plus or minus ib. So here in place of a we have a 0 and in place of b a. So that's why the solution yc is so complex roots. For complex roots, e power ax, what is a here? 0 into c1 cos bx, what is b here? A. c1 cos ax plus c2 sin ax. Right? Now here e power 0x is 1. Then this can be write as c1 cos ax plus c2 sin ax. Now compare with this c1u plus c2v. Then here c1u plus c2v. That's why we get u is cos ax, v is sin ax. Right here where u is equal to cos ax and v is equal to sin ax. These are u and v. Now to find to find particular integration, so actually the particular integration is yp is equal to au plus bv. So in that we have a and b. What is a? So in that we have uv dash minus vu dash. First of all we have to find uv dash minus vu dash. After that we take a particular integration. Now let yp is equal to, what is yp in variation of parameters? Yp is au plus bv. That's why here write what a into what is u? A cos ax plus b, v is sin ax. So this is the particular integral yp. Now so what is a and what is b? So now to find a and b, first of all write uv dash minus vu dash. So what is uv dash minus uv dash? So u is cos ax. Then what is v? Cos ax derivative. So u dash is minus a sin ax. Cos ax derivative is minus a sin ax, and v is, what is v here? V is sin ax. So sin ax derivative, that is v dash. So a cos ax. Now write uv dash minus vu dash. So that's why we get what is u. So cos ax into minus uv dash. So a cos ax, that is uv dash, minus v, what is v? Sin ax into u dash, what is u dash? Minus a sin ax, right? So this is uv dash minus vu dash. Now so here in that a is common, write this one, a into cos square ax, here minus of minus plus sin square ax. So right, so that's why we get cos square plus sin square is 1. So then we get uv dash minus vu dash is a. Now write a. What is a here? So what is a? Here a is minus vr by uv dash minus vu dash. So into dx. Right, now substitute what is u, v dash and vu dash and r minus. So what is v here? V is sin ax into r. What is r? So in given problem r is tan ax by uv dash minus vu dash. Uv dash minus vu dash is a, right here a into dx. Right, now here minus 1 by a is a constant, here integral. So tan ax can be write as sin ax by cos ax. So here sin ax, so then that is write as sin square ax by cos ax into dx, right? Now integral minus 1 by a integral sin square ax by cos x. Now integral of this one. First of all, so here convert into known formula. We have to convert into known formula. Sin square ax can be write as 1 minus cos square ax by, so here cos ax into dx. Right, now this can be write as, so 1 by cos ax minus cos square ax by cos ax. That's why here minus 1 by a integral. So 1 by cos ax, divide 1 by cos ax, 1 by cos is secant ax minus here cos square by cos. So that's why we get a cos ax, right? So into dx. Now separate the integration, minus 1 by a into, so integral secant ax dx. What is secant ax integration? Secant ax integration is 1 by a logarithm of secant ax plus tan ax. This is integral of secant ax, 1 by a logarithm of secant ax plus tan ax minus cos ax integration. What is cos ax integration? Cos ax integration is sin ax by a. So then in that 1 by a is common. Now take this one, minus 1 by a square logarithm of secant ax plus tan ax minus sin ax. So this is the a value, right? So after getting A, then go for B. What is B here? Now, so to write a B, what is B? Here B can be written as B is equal to integral u r by uv dash minus vu dash into dx. Now substitute uv dash minus vu dash and u and r. So now here what is u? U is cos ax into r. What is r here? In given problem r is tan ax by uv dash minus vu dash is a into dx, right? Now here tan ax can be written as sin ax by cos ax. Then here cos ax into tan is write as sin ax by cos ax by a. Now here cos cancel. So write remaining term. So what is here remaining term? So 1 by a is constant integral sin ax dx. So what is sine integration? Sine integration is here 1 by a constant minus cos ax by a. This is the integral of sin ax. Now here write so minus 1 by a square cos ax. This is the b. Now so a and b, write the particular integral. What is particular integral? So the particular integral yp is, what is yp? Au plus, so here particular integration is au, it means a cos ax plus bv, v is sin ax. Now substitute a and b in this yp. So here we get a. What is a here? Minus 1 by a square logarithm of secant ax plus tan ax minus sin ax. This is a into u. What is u? Here u is cos ax plus b sin ax. What is b? So here b is minus 1 by a square cos ax into v sin ax. So we get particular integration. So after getting particular integration, then write a general solution. So what is general solution? The general solution can be write as y is equal to yc plus yp. Now the general solution is what is general solution? So here y is equal to yc plus yp. So already we get a complementary function of yc and a particular integration of yp. This is the particular integration. What is the complementary function here? c1 cos ax plus c2 sin ax. This is complementary function of yc plus particular integration. So what is particular integration? This is the particular integration in these two terms. So minus 1 by a square is the common term. So write minus 1 by a square into, so right here logarithm of secant ax plus tan ax minus sin ax. So here into cos ax. Overally, so here minus 1 by a square is common term. We get plus cos ax into sin ax. So this is the our final solution, right? So here we find so d square plus a square of y is equal to tan x. So we can find similarly for tan x here secant ax or cosecant ax in the similar way, right? So that's just changing r value. So in that r value substitute in place of r secant ax, so we get a and b, right? So secant ax or cosecant ax, right? So we can find solution for different types of problems. So that are for example, see, when r is equal to here tan ax or secant ax or cosecant ax or 2 by 1 plus e power x or e power x into tan x for every problem. I mean for every r, so in different method, different forms, 2 by 1 plus x, e power x tan x or log x, for anyone. So for every these type of functions, tan, secant, cosecant, 2 by 1 plus e power x, for every these functions, so we have to use variation of parameters, solving the type of equations by variation of parameters. So we can find these problems in general methods also. So next class we will discuss what is general method and how to solve these type of functions in general method. Okay, thank you.